Hello and welcome to live chat, Architecting Software Quality live with Andre. Uh, Architecting Software Quality is a series of friendly chats with our just a second. With a series of experts, practitioners discussing topics and sharing war stories, best practices related to topics of software quality. We will be talking about things starting from safety and security, all the way down to architecture patterns. We'll talk about testing tools and methodologies. We'll have some speakers to talk about best practices in DevOps and CI/CD, highlighting the challenges there. But today I'm excited to introduce my guest. His name is Kevin Greene. He is a director of security solutions at Parasoft. He has, I'm excited to have him here because he has extensive experience and expertise in cyber research, development, and DevOps. At Parasoft, he leverages his experience and expertise to help Parasoft create meaningful solutions and technologies to improve software security practices. So with that, I'm going to bring Kevin to the stream. And hi, Kevin.
Hey, how you doing, Andre? Thanks for having me. I appreciate that.
Thanks for being here, Kevin. So my first question to you is, so you worked at that very cool place, the Department of Homeland Security and MITRE. So could you tell me a little bit, maybe a couple interesting facts about what you did there? What was your experience? What you learned?
So working in a federal capacity, leading R&D in the area of software security at the Department of Homeland Security Science and Technology Directorate, this probably was one of the most meaningful parts of my career. I was able to build some really cool R&D capabilities that we see in today's technologies. For instance, if you have been paying attention to the news, two programs that came in, actually one program I had, two companies that were part of my research portfolio was acquired in separate instances by separate different companies. So the research, essentially, some of the research that was part of my portfolio, these individuals' companies, CodeDX is one, and the other is Denim Group. They were able to commercialize some of the R&D that was part of my program, and it was just recently acquired. So one of the things I really enjoyed about working in that capacity is being able to take R&D and commercialize it and get it into the hands of folks who can use it in the operational environments to improve software security. So that was probably one of my most proudest moments, being able to fund R&D and create novel concepts that can really push forward not only the state of practice, but also the state of the art. So I enjoy working with academia as well as small businesses, as well as government, to really try to work on some really hard problems around software security. As you know, with the new EO, there's a glaring attention on software security. So I was very fortunate to work in that capacity to try to push forward the state of practice and state of the art and trying to deliver capabilities that can somewhat help organizations improve software security.
Cool. That's exciting. I immigrated from Russia about 20 years ago, so I was dealing with Department of Homeland Security in a completely different setting than you did.
Yeah.
So
I want to add one other point.
Mm-hmm.
My work at MITRE was very helpful as well. Had a lot of opportunities work with some really good sponsors and helping them formalize their DevSecOps strategies, understanding how to create testing capabilities and the whole shift left approach. I was very fortunate to work on a Tiger team and create a white paper that was approach to help organizations think about DevSecOps and how to implement DevSecOps in their environment. So that was something I was very proud of. Towards the latter part of my time at MITRE, I was very fortunate to try to lead an effort to try to improve CWE compatibility program, really trying to work with industry as well as key stakeholders in industry, I should say, in trying to formalize and adopt CWE more broadly across different organizations so that we can have ways to understand the things that could go wrong in software and be able to codify those things in our daily activities as we build software. So that's kind of my last two stops in my career. I have some other stops as well, but those are my two last stops. So.
Well, you arrived to your best stop, which is Parasoft, of course.
Absolutely.
uh, one of the concepts we talked about with you just over the phone, because now we cannot meet yet, but over the phone, we talked about this concept, which was very interesting for me as a developer in the past, which is the idea of a software minimalism. Like the idea where you want to make sure that you don't put extra stuff, you don't design extra functionality in just because you wanted to, and then you want to remove the unnecessary code, settings, configuration. So maybe could you shed some light about what is your definition of a software minimalism and why it would help in cybersecurity efforts of the organization?
So the concept is really trying to get folks who are building and developing software to kind of only use the things that are really necessary, right? Only things that are necessary, completely necessary to achieve, key broad system qualities, right? Scope qualities, right? And making sure that we're not overboarding software or making software overly complex or just generally creating unnecessary things that is part of building software or even designing software. So I think really building software with just the essential things that are necessary to carry out the functions of the system. So being able to make sure we have good requirements and take those good requirements and build a system and not add a lot of additional things that could really do a couple things, right? One, expose an attack surface. We've seen now with a lot of the attacks is that there's an exposed attack surface because of software, right? And understanding how do we build systems to mitigate that. And really what comes into mind is cyber resiliency. And one of the key principles around that is trying to reduce the attack surface in software. As we see, I mean, this is not only a problem in software design and software engineering, I think it's a problem in daily lives, right? If you go to a restaurant, the first thing they want to ask you, do you want to supersize, right? Do you want to supersize software? No, we don't want to supersize software. We want to build the essential capabilities and functionality in the system. And I think by and large, as a community, as an industry, there are things in our personal lives we see, right? Everybody wants to have more. And a lot of times we hoard things and some things are not necessary. And we see with software, the more that we hold on to things and more we add more complexity, more features, right? More features to systems, the more susceptible we are to security breaches. So the goal of software minimalism is really trying to only build a system with things that are essential to the overall functionality of the application of the system, and really trying to reduce the attack surface so that we can have more resilient software systems and applications.
Thank you. Yeah, it's an interesting concept. So I'm gonna try to throw a monkey wrench into this concept a little bit. So bear with me.
Sure.
I was a developer in the past. So when we were developing applications, one of the concepts was to build a reusable component, which means maybe architecting in such a way that it could potentially be used by other people, not today, but in the future. But it also has a cost. Like when you're architecting for usability, you're probably adding extra layer of API, you're adding extra files, extra documentation, extra configuration files. Even sometimes you add on the top of it an extra framework which could be used by other people in the future. But again, I'm adding complexity in essence into application to allow other people in the future to do less work. But is the idea of a software minimalism, in your opinion, goes against the idea of reusability of components?
I think it varies. I mean, your junk is my junk, right? So if you build something bad, right, in terms of patterns, in terms of models, right, I inherit your junk. And one of the things about using libraries and open source components and frameworks and so forth and so on, we have to be aware of the external dependencies that are associated with that. right? And this part of it is on the developer or those who are developing software. So in this case, we talk about the supply chain, the suppliers, to do their due diligence in understanding the complexity associated with libraries and components. And if you use this or introduce this into your software development environment, what additional risk does will it pose, right? What additional attack surfaces will be exposed by bringing these things in? So I do agree in principle that reusability is common across software development projects and software development practices. But I think there's some onus on those who are developing software to really understand, right? What external dependencies are these things relying on? Because at the end of the day, you lose some control when you bring in external components, right? In terms of frameworks and libraries, you lose some controls because in some instances it's a black box. You don't know what these components and frameworks are doing. So that's why it's imperative that people who are building software, right, they are aware of their design choices as they are bringing software in from different places like open source, and really vet these applications and open source components so they have some idea of what it's doing and what is the long-term effect of using this component. I think that's partially one of the things with reusability. We're not fully aware of the long-term or even short-term to a certain extent risk in using this, right? And so having some awareness and being able to do some type of risk analysis around that, I think is very important for developers, given the landscape we're in with cybersecurity.
Thanks, Kevin. Yeah, so this is interesting, and that leads me to my next question. If somebody is coding an application, right, either in C, C++, Java, whatever other languages, right, they're probably introducing, whether they want it or not, some potential security vulnerabilities that can be exploited. So what would be your advice to developers? How would you want to, what are the principles and methodologies and just kind of cultural maybe changes that needed to be employed to bake security into the code, into the design process right from the start? You've probably seen a lot of examples where it happened, and you've seen probably a lot of examples where it didn't happen. So just from your experience, could you give us some maybe guiding principles?
So I think there are some really fundamental things that we need to understand, right? One is with anything you build in terms of software, least privilege and least functionality is so essential, right? That's like the building blocks of good software design, right? You build a system with least functionality, right? That means you're trying to do whatever you can to eliminate the different attack surfaces, different interfaces you're using. You're trying to lock down the ports. You're trying to lock down things that may be an escalation point for elevated privilege to a system. So at the fundamental part, I think, is really trying to incorporate some aspect of least privilege into the system design. The other thing is, when we design, fundamentally assembling software development has changed, right? It's not much software that's being developed. A lot of it is using open source components and assembling these components together to build a system. I think one of the most important things that what we're starting to see, as indicated in the executive order around cyber, Section 4, software security, is the whole notion of software bill of materials, right? And understanding where components are coming, where are you getting these components from? What's the provenance of these components? What's the risk associated with using these components? Having some understanding of that. What is the hygiene associated with this component? Does this component have a lot of CVEs associated with it? So those decision points are essential in building good software and designing good software. And the other thing is, I think it's important for developers to understand the design, right? So what is the design trying to accomplish? What are the security mechanisms that are part of the design? Because I think it's important for developers to understand that. So when they go to implement those particular security patterns or security mechanisms in code, they are doing it correctly, right? Developers need to be aware of the impact of their daily activities on the design. How are your daily activities eroding design, making design insecure? I think developers have to have an understanding of that. So I think those are things that I think are so fundamental, given that we're building software at a very, very fast pace with DevSecOps, right? And a lot of times we have the ability, to a certain extent, create vulnerabilities faster, right? We have a tendency to take shortcuts, right? And when we take shortcuts, we know that over time, with taking shortcuts, we accumulate technical debt over a period of time. And one of the things that I'm most skeptical about in the era that we're in now with software security is, I think we have accumulated, meaning we, the industry, have accumulated so much technical debt. I'm afraid that we're not going to be able to pay it down in time. And what we are going to start seeing is more and more security breaches that have been associated with software, especially as it relates to supply chain, because taking shortcuts to deliver, right, through a more iterative approach like DevOps, and trying to build faster and deliver faster. I think a lot of people are taking shortcuts, bad designs, and bad designs leads to accumulation of technical debt, poor coding practices, which also contributes to accumulation of technical debt. I'm afraid we're not going to be able to pay it down in time, and we're going to see catastrophic security breaches that will be associated with software. That's my concern. That's one of my biggest fears in this modern era that we're in.
Wow. Yeah. Coming that from you, I mean, I'm trying. I'm also kind of getting concerned as well. But yeah, so you mentioned a couple of things there that I want to maybe touch upon as well. Dig a little deeper there.
Sure.
Design. All right. The fundamental idea of design, Kevin. So you said design is very important, and then you kind of alluded to the topic of a design being a centerpiece of an essential good software architecture. So question, if you were, let's just take hypothetical question, if you were to be hired, let's just say by a large, let's just say automotive manufacturer, in the case of, let's just say in the case of a lawsuit, or in the case of they want to do some extra audit, and then they bring you the very complex software and potentially hardware system where it has user interfaces, it has various sensors, embedded hardware, they have cloud deployment potentially somewhere there as part of a overall car connectivity infrastructure. So they do have very complex kind of operation there. It's a connected car, for example, maybe it's even self-driving car. So you brought it as an expert, outside expert, to just take a look. What are the things that you would normally start? What are the, let's say, top candidates for you to quickly look and see where it smells? Like what are the things you would be looking for?
Well, first thing I wanted to understand is like how much technical debt is associated with the system or application. I think that's important. But in terms of smells, design smells, like for instance, how much infrastructure is needed for simple functionality? Like how much infrastructure do you need to implement simple functionality? Like having some understanding of that is important. The other thing is like what is the undocumented stuff that we see? Like what maps to security requirements? Where's traceability back to normal requirements that are part of the design and the design concept? So having some understanding, like these requirements are mapped to this or that. So having traceability around requirements is important. The other thing is like how rigid is your design? Like if I make one change, how does that cascade down to other things that I need to make changes because I make one change upstream, right? What is the downstream effect of that, right? The other is how much churn and also refactoring is necessary to maintain the system. These are key indicators. Now we start talking code stuff. I think there's key metrics that we can collect around the system that give us some understanding of the design complexity, gives us some understanding of technical debt to a certain extent. Because one of the things we do know, complexity, increases cost as well as time. The overall goal we should all be focusing on is trying to reduce the cost to maintain software. And if we're not doing that in our daily practices, as well as doing, good software engineering, then we're not doing well, right? So the goal is really trying to reduce the cost to maintain software. Because one of the things I've noticed is that given where we are, two things I do know is happening, right? One, the window of exposure is sliding to the right. We're not patching in time. We're not mitigating security issues. And a lot of times we don't know that there are issues, right? The adversary is attacking us before we know, right? So one of the things we do know is the window of exposures keep sliding to the right, which means that it's taking us longer to mitigate and fix systems, which gives an adversary a longer dwell time to do whatever, exfiltrate data, whatever the case, own your systems, whatever the case may be. The second thing we're noticing in a lot of trends and studies is the time to exploit is shrinking. It's shrinking very fast. So we noticed that I wrote about this in one of the blogs I did on Parasoft. We noticed that when the Apache Struts vulnerability, the one that was associated with Equifax, we noticed that there was like a three-day window from the time the vendor announced or released the patch to the time we saw activity on the internet of the vulnerability being exploited. So 3 days is very short, right? It's a very short time. So we have to figure out a way to build better software and design better systems that's not inherent in complexity, right? Because a couple things we know also is that more features means more complexity. More complexity means more code, and more code means more problems, and more problems are cyber attacks.
It's a nice way you put it there. More code is more problems.
Oh, absolutely.
Yeah, well, remember those times when developers, I've heard, were paid by line of code they develop? I think that's where it all started, right? They're like, okay, I need some money, right? Let me code.
But I want to say this here. I do think one of the things I've decided to do as someone who's been in this field is, I want to be an advocate for developers. And a lot of times, developers are getting thrown to the wolves for whatever reason. I want to be an advocate for developers because a lot of times they don't have the right awareness, right training, the right skills, and they don't have people advocating for them. I think a lot of times, when we want to build systems, we reuse stuff, reuse this, but often we got to give developers better options in terms of software quality. We have to give them better options where quality and security are intrinsically in software systems. So when I go choose an open source component, if I don't have any options, and I know that all software has vulnerabilities, what options does developers have to make good design choices about what software, what libraries and components they have to use? So as an industry, we have to do a better job at creating better software options for developers. And I want to be a developer advocate in that regard.
Yeah, it makes a lot of sense. So my last question to kind of wrap it up is, what's your favorite either book or resource online? Maybe it's a conference you'd like to go to, where you get the knowledge about those options, right? Maybe you can point to one or two.
So, I mean, I stay on the internet. I got various sources. I know a lot of really good thought leaders, in industry, a lot of collaboration with folks. But I think, over my past career and my experience, I've really met some really, really smart computer scientists that I know. Like, for instance, Dr. James Hill, who's at IUPUI, who was very instrumental in doing research for me. Bart Miller, who is also at the University of Madison, Wisconsin. He's the father of fuzzing. There's a lot of people Dr. Mehdi Miracoli, who's really big on design and understanding the security aspects of design. These individuals who have done research for me in the past, I like to pick their brain. I like to talk to people. I like to talk to people who have been in the industry to understand, like, where do we go from here? What things work, what things doesn't work. So one of the things I think as an industry, we really have to get rid of things that don't work, right? We got to start rehashing old practices, old things that don't create meaningful impact, meaningful change and improvements in how we do software security, right? We have to do that. So, complexity is a huge problem in trying to test, right? If you don't know what to test, or if there's so much complexity, you can't do effective testing. And if you can't do effective testing, you don't have eyes to find the hot spots, the things that could go wrong in your environment before you release software. So as an industry, I hope we work on that. And I hope hopefully the EO, the executive order on cybersecurity, is a way to do that. And hopefully people will pay more attention to some of the things that have been going wrong in software development. But now, because we're moving so fast, and I mean, the size of software today is humongous, right? So we just got to do a better job of being mindful of that, and be able to codify these good practices in our daily activities, right? So threat modeling and all these different activities that are so essential up front with a concept. So each time a product team wants to onboard new features or functionality, the entire product team should be thinking about ways in which the functionality can be misused and abused, right? That's why threat modeling is so important. It get not only the designers, but also the developers to think like an adversary and be defensive in their programming and their coding practices, so that they can code and mitigate things and not cause vulnerability or create weaknesses, I should say, that expose vulnerabilities in software. So hopefully, we can continue to move forward and make improvements.
Right. All right, cool. Thank you very much, Kevin. In closing, I just want to say that I will be posting some of the resources you talked about, like EO or the blogs that you mentioned, maybe some other useful resources in comments to this broadcast. So thank you very much for whoever listened us live. I know that we had some questions that are actually comment that I got from live, and then we were able to put it on screen. So if you're listening to us, just ask us next time, ask questions, and then we'll be able to kind of have more of a almost like interactive session with our guests. In closing, I just want to say, Kevin, that the people with gray-haired beards are cool. I think that's
No
what
doubt. And thanks for having me. I think we had a critical time in our nation, right, where the software supply chain is becoming a huge risk, and those who are developing software have to take a more assertive effort in making sure we're following good security practices and we have good software hygiene, and we're doing the things that are so necessary to be proactive as opposed to being reactive. So thank you.
Yeah, I agree. Thanks, Kevin. All right. Take care. Bye.
Take care. Have a great